Fine, let's start. Number 1. The Hopewell Airburst. Picture the Ohio River Valley almost 2,000 years ago. This was the heartland of the Hopewell people, a civilization that thrived between roughly 100 BCE and 500 CE. They were not a single tribe, but a vast ceremonial network, and they built enormous geometric earthworks, perfect circles and squares laid out with astonishing precision. Their trade reached across the entire continent. Copper came from Lake Superior, obsidian from the mountains near Yellowstone, and shark teeth all the way from the Gulf of Mexico. These were sophisticated people who understood their world. Then, according to one striking hypothesis, the sky turned against them. In 2022, a research team led by Kenneth Tankersley of the University of Cincinnati published a study in the journal Scientific Reports. They argued that a cosmic airburst, an exploding comet fragment, detonated in the atmosphere over Hopewell territory. The blast may have scorched an area of roughly 9,000 square miles. That is a swath of the ancient Midwest larger than many modern states. The evidence they gathered is unsettling. Across 11 separate Hopewell sites in 3 states, they found a thin layer of strange debris. It contained micrometeorites, tiny fragments of space rock. It held a spike in iridium and platinum, elements far more common in asteroids and comets than in Earth's crust. And it contained melted glass and microscopic spheres that could only form at temperatures above 1,700 degrees Celsius. No ordinary wildfire burns that hot. Something had rained fire from above. The best modern comparison is the Tunguska event of 1908, when an object exploded in the air over Siberia and flattened 2,000 square kilometers of forest without leaving a single crater. An airburst does not need to hit the ground to be devastating. The shockwave alone can level everything beneath it. If Tankersley is right, the Hopewell experienced their own Tunguska, and they had no way to understand what had happened. Intriguingly, some native oral traditions from the region speak of sky serpents and stars that fell to Earth. The researchers suggest these stories might preserve the memory of exactly this kind of event, passed down for many centuries. There is even a Hopewell earthwork near Milford shaped, some say, like a comet. Now, this hypothesis is genuinely contested. Many archaeologists are cautious. Microscopic spheres can come from volcanoes or from modern industrial contamination, not only from space. And the decline of the Hopewell was gradual, spread over generations, tied to shifting climate and changing societies, not obviously to a single fiery night. The airburst idea has not won broad acceptance, but sit with the possibility for a moment. If it is true, then people living in complex, peaceful, well-organized communities looked up one day and saw the sky itself ignite. That is where our story begins, because the terror of prehistoric America did not come from monsters. It came from the world itself. And if the sky could burn, what was waiting in the land below? Number 2. The Carolina Bays. Travel east to the Atlantic coastal plain, and you find one of the strangest landscapes in North America. Scattered from New Jersey, down through the Carolinas, and into northern Florida, are enormous elliptical depressions in the ground. There are an estimated 500,000 of them. And here's the eerie part. They are all oriented the same way. Their long axes point in roughly the same direction, northwest to southeast, as if 500,000 raindrops had struck the land and frozen in place. Individual bays range from under 100 meters across to several kilometers long. Many are rimmed by raised ridges of sand on their southeastern edges. From the ground, they can be hard to notice. But from the air, the pattern is undeniable and deeply unsettling. It looks designed. People first grasped the scale of the phenomenon in the 1930s, when aerial photography revealed thousands of these matching shapes at once. An early and dramatic idea took hold. Perhaps a meteor shower or a great comet had blasted them all into existence in a single catastrophe. It was a terrifying and tidy explanation, and it captured the public imagination for decades. But the science tells a more complicated story. When geologists used a technique called optically stimulated luminescence to date the sand in the bays, they found the bays did not all form at once. Their ages spread across an enormous range, from around 50,000 to 12,000 years ago. A single impact cannot carve features over tens of thousands of years. That finding quietly dismantled the impact theory. The mainstream explanation today is less cinematic but still powerful. During the Ice Age, the coastal plain was a cold, windy place, dotted with shallow ponds. Prevailing winds and wave action slowly sculpted those ponds into oriented ellipses, piling sand on their downwind southeastern rims. That is why the rims are consistently higher on one side. Similar oriented wetlands, like the rainwater basins of Nebraska, form the same way far from any coast. And crucially, no shocked quartz, no meteorite fragments, and no crater ejecta have ever been found in the bays. The bays are more than a curiosity. Their soft basal sediments trap pollen and plant material, giving scientists a detailed record of Ice Age climate along the eastern seaboard, and some preserve the remains of vanished megafauna. Today, they host distinctive wetland ecosystems, from Carolina Bay lakes to boggy moccasins full of rare plants. Many have been drained for farmland, but where they survive, they remain living time capsules of a colder world. Some researchers still argue for a cosmic origin, tying the bays to the disputed idea of a comet strike 12,800 years ago. Investigators using modern laser mapping keep the debate alive in popular media, but most geologists are convinced that wind and water, not fire from space, made these marks. Still, imagine encountering this land as an ancient person. 500,000 glinting, perfectly aligned ponds, stretching to the horizon. You would have no way to know they were carved by patient wind over ages. You might think a god had stamped the earth, and that sense of a landscape shaped by forces beyond comprehension only deepens as we turn to water, because in prehistoric America, water did not trickle. It exploded. Number 3. The Bonneville Flood. In the Great Basin of the American West, there once lay a lake so vast it is hard to picture. Lake Bonneville covered about 51,000 square kilometers across what is now Utah, Nevada, and Idaho. Today, only shrunken fragments survive, the largest being the Great Salt Lake. The pioneering geologist G.K. Gilbert first mapped this vanished sea in a landmark study published in 1890. Around 18,000 years ago, Lake Bonneville rose until it reached a low point in the landscape, a threshold at Red Rock Pass in southern Idaho. And then the threshold failed. Water began to spill over, and as it poured across the soft sediment of the divide, it cut down rapidly, widening the gap. What started as a trickle became one of the largest floods in the history of the planet. The numbers are staggering. Peak discharge is estimated at around 1 million cubic meters of water every second. For comparison, that is many times the flow of the Amazon. This wall of water roared north and west down the Snake River Plain, carving the deep Snake River Canyon and shaping features like Shoshone Falls, sometimes called the Niagara of the West. The flood was so powerful, it moved boulders the size of houses. Geologists call them melon gravel, rounded chunks of dark basalt. Some several meters across, carried dozens of kilometers downstream, as if they were pebbles. You can still find them stranded across southern Idaho, silent witnesses to a violence almost beyond imagining. As the threshold eroded down to bedrock, the lake dropped roughly 108 meters to a new stable level that geologists call the Provo shoreline. The most catastrophic phase may have lasted only weeks, though the draining continued longer. When it was over, an entire inland sea had been partly emptied through a single canyon. The mid-20th century geologist Harold Mauld mapped the flood's deposits in detail across Idaho, and later scientists reconstructed its discharge by measuring the channels it carved and the boulders it moved. Before the failure, the threshold at Red Rock Pass had been holding back an immense hydraulic head, the weight of a continental lake pressing against a plug of loose sediment. When it went catastrophically. Even now, if you drive through northern Utah, you can look up at the mountainsides and see a faint horizontal line etched into them, along with old wave-cut terraces and mineral crusts called tufa. That is the old Bonneville shoreline, the high watermark of a lost sea. Here is the truly frightening thought. Lake Bonneville was just one lake. Across the northern half of the continent, an entire ice sheet kilometers thick was beginning to melt. Bonneville was a preview. The main event, the meltwater catastrophes to come, would dwarf even this. But before the water returned, the ground itself would prove it could kill in an instant. Number 4. The Cascadia Megaquake and the Ghost Forests. Along the Pacific coast, from Northern California up to Vancouver Island, runs a hidden fault nearly 1,000 kilometers long. It is called the Cascadia Subduction Zone, and it is where the Juan de Fuca plate grinds down beneath the North American continent. This kind of fault produces the most powerful earthquakes on Earth, megathrust quakes that can reach magnitude 9. For a long time, nobody knew Cascadia was so dangerous. The clue came from dead trees. Along the coast of Washington and Oregon, there are eerie stands of bare gray tree trunks standing in the salt marshes, killed long ago. Scientists call them ghost forests. The geologist Brian Atwater of the United States Geological Survey realized these trees had drowned suddenly when the coastline dropped 1 to 2 meters in a single moment. Only a massive earthquake could cause that much land to sink at once. Then came the detective work that pinned down the exact date. Tree ring analysis of the ghost forests showed the trees stopped growing after the growing season of 1699. So the event happened in the following winter. And across the Pacific, in Japan, historical records described a mysterious tsunami that struck the coast with no local earthquake to explain it. Japanese scientist Kenji Satake and others matched that orphan tsunami to Cascadia. The great earthquake struck on the evening of January 26, 1700. The wave reached Japan about 10 hours later. This was not a one-time event. On the seafloor off the coast, layers of underwater landslide deposits, called turbidites, record around 40 great earthquakes over the past 10,000 years. The average time between them is somewhere between 300 and 500 years, though the pattern is irregular. Buried soils in the coastal estuaries preserve cycle after cycle of slow uplift, followed by sudden, violent subsidence. The native peoples of the coast remembered. Oral histories from the Huayat, the Makah, and others tell of a terrible night when the ground shook so hard people could not stand. And then the sea rose up and swept away entire villages. These were not myths invented to entertain. They were eyewitness accounts, carried across 10 generations. For the people who lived on that coast in prehistory, this was a recurring apocalypse. Every few centuries, without warning, the land would heave, the shore would drop, and a wall of ocean would erase everything they had built in a matter of minutes. And the fault is not finished. It is locked and loading strain right now. A future great Cascadia earthquake is not a possibility. It is a certainty. But while the coast kept rebuilding, inland, an entire mountain was about to disappear from the face of the earth. Number 5. The Great Drought and the Fall of Mesa Verde. Not every terror in prehistoric America was sudden. Some came slowly, patiently, over years, and that made them worse. In southwestern Colorado stand the cliff dwellings of Mesa Verde, among the most beautiful and haunting ruins in North America. The largest, Cliff Palace, holds about 150 rooms and 23 of the round ceremonial chambers called kivas. Roughly 100 people once lived there, tucked into a great alcove in the canyon wall. The ancestral Puebloans built these cliff villages mostly between the 1190s and the 1270s. We can date them with remarkable precision thanks to tree ring dating, a method pioneered by the astronomer A.E. Douglas in the early 20th century. Every wooden beam carries a signature of the years it grew, and those same tree rings recorded something ominous. Beginning in 1276 and lasting through 1299, the Colorado Plateau suffered what scientists call the Great Drought, 2 decades of failing rains. Look closely at the timing, and a grim story emerges. These people did not always live in the cliffs. For centuries, they had farmed the open mesa tops. The move into hard-to-reach cliff alcoves, accessible only by ladders and handholds, happened late, and it speaks of fear. As water and food grew scarce, communities turned defensive. They pulled back into fortress-like positions in the rock, and the violence was real. At a site called Castle Rock Pueblo, archaeologists, including Kristen Kuckelman, documented a massacre around 1280. People were killed where they lived. The social order that had held these communities together for generations was breaking down under the pressure of drought and hunger. By around 1300, the entire Four Corners region, once home to perhaps 20,000 people, was almost completely empty. Archaeologists call it the depopulation, or the Great Migration. The ancestral Puebloans did not simply vanish, a point worth stressing. They moved south and east to the Rio Grande Valley and to the lands of the Hopi and Zuni, where their descendants live to this day. But their ancestral homeland was left silent. The causes went beyond drought alone. Generations of farming had depleted the soil. The forests had been cut for fuel and construction. Cooling temperatures shortened the growing season, and the earlier great center at Chaco Canyon had already collapsed as a political power around 1150. It was a cascade of failures, with climate as the final blow. Archaeologists can see the desperation in the ground itself, in the check dams, terraces, and reservoirs the ancestral Puebloans built to squeeze every drop from a drying land. In the end, none of it was enough. The cliff villages themselves lay forgotten by the outside world until 1888, when a rancher named Richard Wetherill stumbled onto Cliff Palace while searching for stray cattle. The cliff dwellings were occupied for less than a single century before they were abandoned forever. Walk through them today, and you feel the silence. Ladders still lean against empty doorways. It is the eeriest kind of terror. Not a bang, but a slow strangulation. And yet climate could do something far more violent than a drought. It could reverse the world itself. Number 6. The Mazama Eruption and the Birth of Crater Lake. In the Cascade Range of Oregon, there once stood a great volcano that geologists call Mount Mazama. Around 7,700 years ago, it erupted with a fury almost impossible to comprehend. On the scale that measures volcanic explosions, this eruption rated about a 6, and it hurled out roughly 50 cubic kilometers of molten rock and ash. To grasp the scale, consider that this eruption was about 40 times larger by volume than the 1980 eruption of Mount St. Helens, which itself devastated a huge region. Mazama's blast sent pyroclastic flows, avalanches of superheated gas and rock, racing tens of kilometers from the vent. Ash fell across the entire Pacific Northwest and drifted as far as present-day Canada and the northern Great Plains. Then came the collapse. So much magma had been expelled that the mountain could no longer support its own weight. The summit caved inward, forming a vast bowl-shaped caldera about 8 by 10 kilometers wide. The mountain, quite literally, destroyed itself and fell into the void beneath it. Over the following centuries, rain and snowmelt slowly filled that caldera with water, creating Crater Lake, the deepest lake in the United States at 594 meters. It has no rivers flowing in or out. Its intense blue color comes from the sheer purity and depth of the water. Here is what gives this event a special power. People saw it happen, The ancestors of the Klamath people lived in the region, and they preserved the memory of the eruption in oral tradition. Their legend tells of a battle between Lao, the spirit of the underworld who lived in the mountain, and Skell, the spirit of the sky. In the story, the mountain is destroyed and collapses. That is an astonishingly accurate account of a caldera-forming eruption, remembered for more than 7,000 years. We know people were there because archaeologists have found their belongings buried beneath the Mazama ash. At Fort Rock Cave, sandals woven from sagebrush bark were discovered under the ash layer, proving humans walked that land before the mountain fell. The geologist Howell Williams produced the classic reconstruction of the eruption in 1942, and to this day, the Mazama ash serves as a precise time marker layer that archaeologists use across the region. Imagine standing in a valley and watching an entire mountain tear itself apart, the sky going black with ash, the ground trembling, day turning to a choking twilight that lasted for weeks. For the people who witnessed it, this was the end of a world. And yet even fire on this scale was not the greatest climate terror the continent held. Because next, the world tipped back toward ice. Number 7. The Lake Agassiz Outburst. As the last ice age loosened its grip, the Great Laurentide ice sheet that covered much of North America began to melt. All that meltwater had to go somewhere, and much of it pooled into an inland sea of almost unbelievable size. Geologists call it Lake Agassiz, named by Warren Upham after Louis Agassiz, the scientist who first championed the idea of ice ages. At its peak, it covered more than 440,000 square kilometers, spanning parts of Manitoba, Ontario, Minnesota, North Dakota, and Saskatchewan. It held more water than all the modern Great Lakes combined. This lake was held in place by walls of ice, and ice dams are treacherous. As the climate shifted and the ice margins moved, different drainage outlets would suddenly open and close. Around 12,900 years ago, scientists believe one of these barriers gave way, and a colossal surge of cold freshwater rushed out toward the North Atlantic Ocean. That flood of freshwater had a consequence that reached far beyond America. The North Atlantic is home to a vast system of ocean currents, sometimes called the Great Ocean Conveyor, that carries warm water north and keeps much of the northern hemisphere mild. The scientist Wallace Broecker argued that dumping a huge pulse of freshwater into the system could shut it down, and that is apparently what happened. The conveyor faltered, and the climate plunged back into near glacial cold. This cold snap is called the Younger Dryas, and it lasted around 1,200 years. It shows up sharply in the ice cores drilled from Greenland, where the record reveals temperatures dropping several degrees within just decades. An entire warming world was thrown into reverse, and the people and animals of North America had to endure a return to the cold they thought was ending. There is still debate about the details. Scientists argue over whether the triggering flood escaped eastward down the St. Lawrence or northwestward down the Mackenzie River. And there was a second act. Around 8,200 years ago, Lake Agassiz finally drained for good into Hudson Bay, causing another abrupt cooling event and possibly raising global sea level by a few meters in a geological instant. The bed of this vanished lake became the Red River Valley, some of the most fertile farmland in North America. Ancient beach ridges from its fluctuating shorelines still run across the northern plains, like the rings of a bathtub. But the lesson for the ancient Americans was stark. The climate was not stable. It could lurch from warm to frozen within a single human lifetime. And while water could freeze the world, it could also carve a landscape to pieces in a matter of days. Number 8. The Missoula floods and the channeled Scablands. In western Montana during the Ice Age, a lobe of the Great Ice Sheet pushed south and dammed a river valley, creating glacial Lake Missoula. This lake held up to about 2,000 cubic kilometers of water, comparable to Lakes Erie and Ontario put together, and that ice dam was doomed to fail. When it did, it released one of the most violent floods the planet has ever known. Then the dam reformed, and the whole thing happened again and again, dozens of times over roughly 2,000 years. The story of how we learned this is one of the great dramas of science. In the 1920s, a geologist named J. Harlan Bretz studied the strange, scarred landscape of eastern Washington and concluded that only a catastrophic flood could explain it. The scientific establishment of the day rejected this fiercely because geology had committed itself to the idea that landscapes change only slowly over vast time. Bretz was accused of reckless thinking. But another scientist, Joseph Pardee, identified glacial Lake Missoula as the source of the water, supplying the missing piece. Decades later, Bretz was fully vindicated, and in 1979, at the age of 96, he received the Penrose Medal, the highest honor in geology. The landscape these floods carved is called the Channeled Scablands, a vast network of dry canyons, scoured basalt, and abandoned waterfalls across the Columbia Plateau. The most spectacular feature is Dry Falls, a former waterfall 5.6 kilometers wide and 120 meters high. When the floods were flowing, it dwarfed Niagara many times over. The raw numbers defy belief. Peak discharge is estimated at around 17 million cubic meters per second, which is faster than all the rivers of the world flowing together. The water left behind giant current ripples like those on a sandy stream bed, except these are up to 15 meters tall and spaced hundreds of meters apart. It scattered ice-rafted boulders, carried inside floating icebergs, across the landscape far from their origins. At a bottleneck called Wallula Gap, the floodwaters backed up faster than they could drain, pooling into a temporary body called Lake Lewis. The water rose so high it surged into tributary valleys, and erratic boulders from the flood ended up near present-day Portland in the Willamette Valley of Oregon. At places like Burlingame Canyon, geologists can count layer upon layer in the flood sediments, 40 or more separate events recorded in the rock. The floods stripped the soil down to bare bedrock across enormous areas, leaving the scabbed, wounded terrain that gave the Scablands their name. The whole cycle was tied to the advance and retreat of a tongue of ice called the Purcell Trench Lobe, which formed and reformed the dam over and over. This was a landscape carved not over millions of years, but in a matter of days, by walls of water hundreds of feet high moving faster than a car. Land shaken, land drowned, land frozen. And then, finally, the terror came from space itself. Number 9. Meteor Crater, Arizona. On the high desert plateau of northern Arizona, near the town of Winslow, there is a hole in the ground so perfect it looks artificial. Meteor Crater, also known as Barringer Crater, is about 1,200 meters across and 170 meters deep, with a rim that rises 45 meters above the surrounding plain. It is one of the best preserved impact craters on the entire planet, and it was made in an instant. About 50,000 years ago, during the Ice Age, an asteroid made of iron and nickel came screaming out of the sky. This object, known as the Canyon Diablo meteorite, was roughly 50 meters across, about the size of a large building. It struck the Earth at somewhere between 12 and 20 kilometers per second. The energy released was equivalent to around 10 megatons of explosive, hundreds of times more powerful than the first atomic bombs. The impact was so violent that most of the iron asteroid simply vaporized or melted on contact. This actually created a scientific mystery for a long time. Because there was no giant buried lump of iron to find, many early scientists doubted the crater had a cosmic origin at all. In 1903, a mining engineer named Daniel Barringer became convinced it was an impact site and spent years and a fortune drilling in search of the iron body he believed lay beneath. He never found it because it no longer existed as a solid mass. The proof finally came from the geologist Eugene Shoemaker. In 1960, he identified two rare minerals in the crater, coesite and stishovite. These are forms of silica that can only be created by the shock pressures of an impact. Shoemaker's discovery not only settled the debate about Meteor crater, it gave scientists the tools to recognize impact craters all over the world, and even on the moon. He later trained Apollo astronauts in this very crater before they flew into space. The ground around the crater still holds the evidence. Shatter cones, distinctive fractured rocks, point back toward the blast. The iron fragments scattered across the plains contain tiny diamonds, formed by the crushing force of impact. And here is the haunting detail. When this asteroid struck, North America was alive with Ice Age creatures. Mammoths and giant ground sloths roamed the region. The blast would have obliterated everything for miles, with a fireball, a shockwave, and a rain of debris. There is no proof that humans in the Americas witnessed this particular impact 50,000 years ago. But the crater stands as a permanent scar, a reminder that in prehistoric America, death could come from the ground, from the sea, from the ice, and from the sky. Which brings us to a bigger question. What do all of these terrors, taken together, actually tell us? Step back and look at these 9 catastrophes together, and a pattern emerges. Prehistoric America was terrifying, not because of any single monster or menace, but because every element of the natural world was lethal and active at once. The sky delivered fire in the Hopewell Airburst and the Arizona impact. Water arrived not as rain, but as apocalypse in the Bonneville Flood, the Missoula floods, and the draining of Lake Agassiz. The solid earth itself proved treacherous, dropping the coastline into the sea at Cascadia. Fire erupted from below when Mount Mazama tore itself apart, and a slower terror stalked the land in the form of the Great Drought that emptied Mesa Verde, while the strange scars of the Carolina bays showed how even the quiet coastal plain had been shaped by forces beyond human control. What makes this list so striking is the range of speeds. Some of these terrors struck in seconds. An airburst or an asteroid impact gives no warning at all. One moment the world is ordinary, the next it is fire. Others unfolded across decades, like the drought that slowly strangled a civilization until its people had no choice but to walk away from their homeland forever. Between those extremes lay floods that carved canyons in days and earthquakes that reshaped coastlines in minutes. And crucially, none of these events left the land the same. Every flood, every eruption, every impact reshaped the terrain that later peoples would live upon. The ancient Americans built their lives on ground that had already been ravaged and would be ravaged again. To understand just how relentless this was, it helps to lay these events out across the immense span of deep time. Arrange these events in order, and the sheer persistence of the danger becomes clear. The oldest terror on our list is Meteor crater, punched into Arizona around 50,000 years ago. The Carolina bays were forming across a huge window, from about 50,000 down to 12,000 years ago. Around 18,000 years ago, the Bonneville Flood roared down the Snake River. In the window from roughly 15,000 to 13,000 years ago, the Missoula floods swept across Washington again and again. Then came a cluster of climate shocks. About 12,900 years ago, the Lake Agassiz outburst helped plunge the world into the Younger Dryas cold snap. Around 8,200 years ago, the lake drained a second time, triggering another abrupt chill. Roughly 7,700 years ago, Mount Mazama exploded and gave birth to Crater Lake. The terrors continued right up to the edge of written history. The proposed Hopewell Airburst falls somewhere around 300 CE. The Great Drought emptied Mesa Verde between 1276 and 1300 CE. And the last great Cascadia earthquake struck in the year 1700, less than a lifetime before European settlers would spread across the continent. The message of this timeline is simple and sobering. The terror never stopped. It stretched across tens of thousands of years, from the deep ice age all the way to the doorstep of the modern world. One of the most remarkable threads running through these events is human memory. Again and again, the people who witnessed these catastrophes found ways to preserve them, encoding the events in story and passing them down across staggering spans of time. The Klamath legend of Lau and Skell captures the destruction of Mount Mazama with uncanny accuracy, a memory carried for more than 7,000 years. It describes a mountain that was destroyed and collapsed, which is exactly what the geology confirms. The same is true on the Pacific coast. The oral histories of the Huayat, the Maka, and neighboring peoples describe a night of violent shaking followed by a devastating wave. For a long time, outsiders dismissed these as mere folklore. But when scientists finally dated the Cascadia earthquake to the year 1700, they realized the stories were precise eyewitness records, faithfully transmitted across 10 generations. Even the Hopewell Airburst hypothesis leans on this idea. The sky serpents and falling stars in regional traditions may be the distorted memory of a fiery night from almost 2,000 years ago. This is a profound thing to consider. In a world without writing, human beings still built archives, using the only technology they had, which was story. Catastrophe became myth, and myth preserved the truth. And yet, for all we have pieced together, a great deal remains genuinely uncertain. It is worth being honest about the limits of our knowledge, because several of these terrors remain fiercely debated. The Hopewell Airburst is the most contested of all. While the research team found compelling chemical signatures, many archaeologists remain unconvinced, noting that the tiny spheres and metal traces can have other explanations, from volcanoes to modern contamination. The case is intriguing, but not closed. The Carolina Bays sit at the center of a similar tension. The mainstream view, backed by dating and the absence of any impact debris, holds that wind and water shaped them over ages. Yet a determined minority still argues for a cosmic origin, and the younger Dryas itself is wrapped in controversy. Most scientists favor the meltwater trigger from Lake Agassiz, but a rival camp insists a comet impact caused the cold snap, a hypothesis that has been repeatedly challenged. Even the outlet of the Great Flood is uncertain. This uncertainty is not a weakness. It is how science works. Remember that J. Harlan Bretz was ridiculed for decades before the Missoula floods were accepted, because the idea of sudden catastrophe offended the geology of his time. The lesson is humility. Some of these terrors are beyond doubt, carved in stone and boulder. Others we are still arguing about, and a few may hold surprises that will rewrite what we think we know. What is certain is that the forces behind these events have not gone away. Here is the uncomfortable truth. These are not merely stories from a distant, finished past. The same forces are still at work beneath our feet. The Cascadia subduction zone is locked and quietly accumulating strain right now. And by geological reckoning, another magnitude 9 earthquake and its tsunami are not a matter of if, but of when. Millions of people live in the danger zone today. The volcanic systems have not gone quiet either. Yellowstone and the Long Valley caldera in California remain active supervolcanoes, capable in principle of eruptions far larger than Mazama. Drought and abrupt climate change, the slow terror that emptied Mesa Verde, are threats we are wrestling with in our own century, and the fate of the ancestral Puebloans stands as a warning about what happens when the water runs out. And far above, near-Earth objects still cross our path, carrying the same potential for airbursts and impacts that scarred Arizona and, perhaps, the Ohio Valley. The land that terrified ancient Americans is the same land we live on. It is not tamed. It is simply between catastrophes. Recognizing that is not a reason to live in fear, but it is a reason for a certain humility about our place on a restless planet. So why was prehistoric America so terrifying? The answer, in the end, is not monsters. It is that the continent itself was young, raw, and unfinished, a place where the sky could burn, the sea could rise up and swallow the coast, the ground could split, the mountains could explode, the ice could return, and the rain could simply stop and never come back. Every generation of ancient Americans lived on top of that possibility, without the science to name it or the technology to escape it. And yet they endured. They rebuilt their villages after the wave. They walked to new lands when the drought won. They turned the terror into stories so their descendants would remember. The scars of those ancient catastrophes are still all around us, in the craters and the Scablands, in the ghost forests standing silent in the tide, and in the empty cliff cities waiting under the Colorado sun. Look at the land with those events in mind, and it stops being mere scenery. It becomes a record of survival, written by a continent that has always been, and remains, gloriously and terrifyingly alive.